welcome to this second speaker series from Fellows Fund. I wanted to spend a couple minutes to describe the fund behind these events, and in particular to many of the individuals in this group. You'll be interested in learning about something that your peers are doing, which is joining our Investing Fellows program. So just a couple minutes before we turn over this to the speakers. So right now, as you know, there's a lot of money being poured into the venture ecosystem. But when we looked and considered the specialty of AI investing, we felt that there was a gap because while there's very few individuals like the speakers who have deep production experience developing and implementing AI systems, researching and building out the type of critical know-how, we found those are the people that would be building this unprecedented change, but that a community didn't exactly exist for them. And we found that individuals, when they were out starting their own entrepreneurship journey, they really, within the AI space, needed access to capital, but that has become more and more available. But really, they needed investors that understood what they were trying to do, that understood the technology, that could provide introductions to critical customers and add candidates to help grow their team and achieve the success that they dreamed of. When we think about the history of venture investing, it hasn't always been a specialty driven business, but still the capital had been really sort of a game of a few, and VCs had sort of become gatekeepers, we believe, within some of the AI progress that could happen, because partly they didn't invest in what they didn't understand. And very few VC partners have advanced STEM degrees, and when they go out and try to see what's coming next, if they can't understand it, then they might not invest in it. So what we ended up doing was trying to build this investing community focused on the idea that cooperation would between all of the individual parties would happen if we had the right incentives. And so what we ended up doing was we built out this expert community, of which you'll learn more about in the next slide. And we decided that we would incentivize this community by providing them a majority of the fund's profits to incentivize them to help grow the community and provide customers and critical hires. The idea being that the builders would really benefit from the creation and value that they're doing. If you could be involved in, you might work at Facebook, but if you could have been one of the investors at Facebook, there was a tremendous amount of value created. And since a lot of the early understanding of these AI companies is known by so few people, we felt by bringing everyone together to help solve all of the critical problems and support each other, we could create a really formidable new model. So what we've already assembled is a set of distinguished fellows who span industries and have incredible experience throughout their careers, often IEEE or ACM fellows across a wide range of industries. XD, who I saw was in the meeting, CTO and technical fellow at Microsoft Azure AI. Vijay, who will introduce afterwards, SVP in engineering and chief AI officer of ServiceNow. Charles, the first Amazon fellow and the former MD of global machine learning at Goldman Sachs and a professor at UC San Diego. Haishun, VP of engineering at Instacart. Deepak at Pinterest. Liang at Twitter, and Stefano. So really what we've been able to put together is a group of individuals who are all trying to contribute to the success of the entrepreneurial community within AI and they really understand it well. These are the absolute leaders in the space. And this is a small part of the group that we will eventually assemble, be around 50 or 60 individuals. But for those that are a little bit earlier in their career and want to really learn side by side in this fellowship model, we've introduced a program called Investing Fellows, where you'd collaborate with these distinguished fellows for 2 years and support about 15 investments with a fund buy-in of about $50,000 per year. So if this is something that seems interesting to you, we've got over 30 peers at engineering managers at Google and Facebook and Airbnb that have been reviewing our documents and are interested in joining. If this is something that's interesting, please reach out to alex@fellows.fund. We'll set up a meeting and go through more of the specifics. But for now, really, this meeting is an opportunity to learn and make connections. And that's a huge part of the community offering that we've had. XD and the CEO of Zoom, Eric Yuan, previously gave our last in-person chat, Tech Entrepreneurship in the AI Era. And we'll continue to do these about once every 2 months or so, covering a different space as we expand our investing focus and try to include more people. So without further ado, I'm very pleased to introduce Joseph, Sirosh, and Vijay Narayanan, who will be talking about the question, what's the next big wave in AI, consumer enterprise? We've had an opportunity to review some of the questions that you provided when you RSVP'd. But as a reminder, if you are either on LinkedIn or on Zoom, if you use the chat window at the appropriate time, the speakers will try to address your questions in a topical way. So very pleased to begin, and thank you so much for joining us.
Thank you, Andrew. And thanks for the introduction. Welcome, everyone. Welcome to our second fireside chat in the Fellows Fund series. It's my very distinct pleasure to welcome today's guest, Joseph Sirosh, the CTO of Compass. I'll just give a quick intro to Joseph. He has very rich experience having developed AI applications in a number of industries, all the way from research in academia and then working in research labs in the industries, and now building platforms and products across a number of companies, both in the consumer and the enterprise space. First, after his PhD in UT Austin in computational neuroscience, he worked at HNC, which later was acquired by FICO, Fair Isaac Corporation. There, he started with risk management and applying neural networks for fraud detection, eventually rising to be a VP there, leading an advanced technology division focused on machine learning. Then he joined Amazon, where he was first he founded and led the transaction risk management division, and saw the explosive growth there, and also pioneered machine learning in Amazon. And then I think he grew to be the CTO of their global consumer business, leading both the inventory and the supply chain divisions. Then in 2013, I believe I had a great fortune to work with Joseph when he joined Microsoft as the corporate vice president to build the Azure AI platform, including Azure Machine Learning and also a number of Azure AI cognitive services, the data platforms subsequently, and eventually became the CTO of Azure AI. And about a couple of years ago, he joined Compass, the company that's using technology to disrupt real estate, where he now serves as the CTO. Welcome, Joseph. Very impressive credentials and experiences birthing and applying machine learning over the years. Great.
Thank you, Vijay. Thank you. You've been very generous in the introduction, and you yourself have a very distinguished background as well. So it's a pleasure to join you. And I know lots of people here on the call as well, some of whom I'm very familiar with, extremely distinguished. So in many ways, I'm very honored to be talking to all of you and take your questions.
Thanks, Joseph. So I just wanted to get your perspectives on something very broad as well. So you've basically, I would say, seen the evolution of machine learning for the last 20 plus years, and both in research and also its applications in the industry in a broad number of areas. When you look back over these years, are there 2 or 3 areas, applications that you think started out as more of vision in that period, like early days vision, hey, wouldn't it be nice to be able to do something like this? And then having to see it come to fruition and having broad impact at scale today. Are there a couple of 2 or 3 applications you could walk
Yeah,
us?
very interesting question, Vijay. I actually harken back to my early days in my first job at HNC Software in San Diego. Now, the company was one of the neural network companies that the first machine learning company to go public in '95. Very few people knew about it. But they were really a neural network pioneer, and they had even developed hardware in '92 for accelerating neural networks, systolic array hardware. And in the '95 timeframe, they had successfully created a verticalized product for financial services for real-time fraud detection on credit cards. And that was great. That was a great application. But at that same time, there was an enormous amount of creativity that happened at the company. They had come up with a technology called context vectors, which are very similar to embeddings right now. They had figured out how to put it in the cookie, in the browser cookie, and adapt and learn that context vector to the pages that users were clicking on. And ads had an appropriate context vector as well, which adapted to what users were clicking on those ads. And so both of these vectors adapted to each other. And so they had a system in '96 for ad targeting. And it was applied at the first e-commerce companies, but they couldn't take it very far because it was not scalable. I mean, the internet was just starting off in the late '90s and the .com phenomenon was just happening. But I look back at those things created at the time. They created a first semantic search engine using context vectors, ad targeting using context vectors. And those did not really become successful applications. But now, when you look at the last 5 years, embeddings have become the standard. You're using this approach in a modern way, if embeddings being the vectors, and doing all of those similar things, whether it be recommendations, whether it be ad targeting, or of course, classification and other tasks, and search-related things. So that's an example where vision has come to fruition as applications maybe 15 years later, or even 20 years after it was first invented.
Yeah, that's awesome. During this period, on the flip side, anything that you thought was were some of the big disappointments that you think might take off and for various reasons hasn't really panned out?
Yeah, I mean, look, when I took my first neural networks class back in spring of '90, I mean, I learned backprop and neural networks. I mean, I thought it was honestly, it was interesting but boring, right? Because it was just a simple function approximation. And since then, the reason I went into more computational neuroscience in my PhD was I really wanted to, reason, and I wanted to understand how higher order thought, and even concepts like how do we segment objects in an image, or how does our brain actually construct higher order inferences and higher order concepts. So those things are unfortunately still not solved, right? And my hope was, at that time even, we were thinking about very large neural networks with lateral connections and hierarchies, like the neocognitron hierarchies, et cetera, and how that might lead to higher order concepts. And then there was optimism about chaotic dynamics of neural networks, about oscillations in large neural networks, grouping together features to create an object and segment it out from the background. None of those things seem to have panned out. And so the disappointment for me in many ways is we are still in the function approximation stage. We're doing function approximation even better, and clearly lots of applications for function approximation, right? Far more than we thought function approximation would be useful for. That's exciting and that's awesome, but it's in some ways disappointing that true memory, reasoning, higher order understanding of concepts have been taken up to the point where it is useful.
That's awesome. Yeah, couldn't agree more.
Well, what's your take, Vijay? Anything else that come to mind?
No, I think, as you said precisely, the notion of reasoning, I think, is still something that seems very out of grasp. And something that does seem a little bit concerning is there's a lot of hype that today the large networks, neural networks, the foundation models, etc. Are we attributing too much more quote unquote intelligence to them, right? Still, they seem to be efficient at learning patterns in some high dimensional space and being able to efficiently retrieve content. So are they just better? Are they just efficient memorizers and interpolators in a sense? Is there any real reasoning involved? I think that's I would agree with you.
Yeah, and in those early days when I was starting my PhD, so there was lots of research going on things like episodic memory. How is an episode actually remembered? And we really haven't made progress on how could we in a computer system properly remember an episode that happened and reconstruct and reason about it. So lots of room for innovation, by the way, right? That's what keeps us keeps things exciting.
There were a number of questions that came through through the RSVP. So I will try to weave in some of those questions during the course of our discussion. And again, for folks on the call today, if you have any questions, please feel free to shoot them in the chat window on Zoom, and Joseph and I will try to address them. Perhaps not in the order we see them, but maybe thematically as they fit in, we'll certainly address them. Any bold claims today that you would believe?
Maybe you should ask about self-driving cars. Do I believe that?
Yeah.
I think it's
I know you were one of the very first ones to buy the Tesla. Maybe in
yes,
2012 or 2013 when they came
Indeed.
out.
Yes. I mean, it still feels like 10 to 20 years away. But one thing that was very impressive during the Tesla AI day was how they were talking about reasoning in 4 dimensions with space and time. And I think there is exciting progress there, partly driven by the amazing advances in GPU and our compute capability.
Yeah. Let's maybe perhaps switch to the more core topic of today's conversation: consumer and enterprise AI. Right. So there are multiple questions that one could talk about this, but generally it seems that in the last 10 years or so, AI has addressed a lot of questions, but also the applications and benefit have very disproportionately been realized in the consumer space. Enterprise still seems very early in terms of maturity. Any thoughts around what are some of those some big differences? Why do we see this gap? And you worked in both of those spaces, so you seem very to address this.
Yeah, it's a great question. So when I look at the enterprise, one of the fundamental differences I see is that enterprises are really always about automation. A lot of it is about creating efficiency, unless you consider companies like Apple enterprises in the sense that they're creating products that have AI in them, right? So I would, create the distinction of looking at companies that are in the insurance space, banking space, in any of those cases. So when you look at enterprise automation, the problems there generally tend to be a lot harder, and there is less data associated, less data density, if you will, associated with the task that you need to automate. And yet another thing that comes into play is the parallel of Aiml's law. I mean, many of you know, in Aiml's law was a concept where if you had one unautomatable part, and if there was something that was highly automatable or parallelizable because of Aiml's law, your maximum automation was bottlenecked on that one unautomatable part. So if your code task took 1 hour and then there were 19 hours worth of automatable task. Even if you reduce the 19 hours down to 0, you will still be left with 1 hour. So the maximum theoretical speed up is limited. And so something very similar happens in the enterprise when there is a workflow to be done, and there is a human component that's actually not automatable. And then there's a whole bunch of other pieces that are automatable. The total efficiency that you can really maximally hope to get, it tends to be constrained by that human component that is not automatable. And therefore, like orders of magnitude kind of improvements tend to be generally hard in like a meaty workflow. I mean, you can take slices of it and say, hey, this particular thing became 100x faster, but it doesn't necessarily make as much of an efficiency difference. And that's one really interesting thing. And the sort of a corollary to that, one thing that I've found is that when you actually automate the automatable portions, then you hire people for the non-automatable portions, and the number of people that you have accumulate in the non-automatable portions, and that non-automated portion becomes a significant portion of the employment of a company. In fact, which was very funny when I was talking to someone who was in Alexa, and they were telling me how many people were labeling speech for Alexa. There were approximately 4,000 to 5,000 people labeling for Alexa. And the immediate thought that came to mind was, look, we're actually creating employment with AI, not reducing employment. So that's one of the fundamental characteristics in many enterprise workflows that I've found, which is there are some non-automated portions that, unless you can somehow make a breakthrough and eliminate that portion, significant efficiency gains just with AI are not that easy to come up with. So that's one. In the consumer space, but I think compared to the past, with advances like robotic process automation, which actually really provide a framework for automating workflows across screens. It was Selenium plus AI, if you want to think about it, when companies like UiPath brought Selenium plus AI and automated a workflow, then it suddenly caught on, and lots of companies in the traditional enterprise space are starting to use that to create workflow automation and efficiency. So it's a very promising area, but you need to bring that kind of breakthrough together.
Yeah. So it's interesting that you mentioned that the primary use of AI in enterprise would be in automation. I also believe that assisting humans in their day-to-day works is probably going to be another big area as well, right? So if you look at, for instance, just the number of people within enterprises that are, say, looking for information or looking to resolve something. I mean, all of us have questions to things like, hey, our finance department, or HR department, or legal, or facilities, all those types of things. And even customers, right? The whole notion of support for customers. Where a lot of tasks become these very low complexity, but fairly large in volume, right? Hey, change the 401k beneficiary information or whatever, right? So it does feel that those types of things for the people who are delivering those services on the other side, that's probably a very rich opportunity to bring information to them in context at the time that they need it. To also assist those.
Yes, I agree. It's a great point, Vijay. And so let me put that in the context of an example. So if I'm now in the process of building a real estate platform. I chose to go into an industry, a very large one, and revolutionize that through platformization, and AI is part of that whole thing, right? And so one thing that you find in the case of even a real estate transaction is there are certain workflows that can actually be automated. But it turns out there are so many exception conditions that exceptions dominate and humans have to be there. So in a real estate transaction, maybe 30 to 50% of these things can actually go through a workflow. But then there's a big long tail of 50% use cases where you can't just have prescriptive workflows because there's so many branching patterns there. So in that 50%, well, what you can do is make the information accessible, and like the choices that humans have to make, be much more empowered with data, AI, and information. So now at that point, so there's one portion that is automated through software, another portion that is assisted, that is assistive AI to humans, just making the humans just work more efficiently and faster. So absolutely, I think those two go hand in hand.
Yeah, yeah. I was just looking at it, some of our applications internally within ServiceNow recently. In fact, I was talking about a month ago to our CIO. Turns out that internally here, at least, we are able to automate about 70 to 80% of all the interactions that our internal employees, like 12,000 employees, are having with ServiceNow, right? So especially with COVID, the types of questions, the types of things that that employees want to know has really grown exponentially, and about 70-80% seem to be automated. But also, to your point, the remaining 20-30% with these assistive technologies, there is almost 20 to 50% reduction in the turnaround times, right? In the resolution times. Yeah. So it looks like there is probably something there. That's well. Cool. In terms of so you mentioned about some of the challenges, especially on the enterprise space. You mentioned about data being, especially the volume of data and having that. Any other challenges that you see, for instance, some of the things that around explainability or being able to look at robustness? I mean, I'm like consumer space, for instance, especially when you're running experiments on like 100 million users. I'm sure we've all done this, is you run an experiment, take an A/B test, 10 million users in each bucket. You measure your some overall objective evaluation criterion, look at the delta, and if it's statistically significant, you say go ship. Except that it's possible that there could be a small segments of users here and there where maybe the experience actually degraded, right? Yeah. Something that you did. It feels like enterprises, for instance, if you're going to do a chatbot for a customer support for a large enterprise, you really can't afford to have those types of catastrophic failures as well.
That is correct.
So,
yeah.
Any other examples like that you think are also relevant in the enterprise space?
Yeah, I'll give you an example from our own case in Compass. So we have a model that predicts when a home is likely to sell. Or predictively understand if somebody is going to put a home up for sale. We actually have a pretty good model, because it turns out by looking at how long an owner has occupied a home, at what rate a home sells in a particular location, et cetera, we can predict when a home will come on sale. Is it going to happen in 12 months or later? Well, that's useful for agents to go and approach a homeowner and say, hey, I'll provide my services to you. Except when we built the model, we found the challenge of the public records data was huge, which is we had this really unusual target leaker situation that happened, where when a home was actually sold, its data was rich. When a home was not on the market, it had little data associated with it. So when we built the model, we did the missing data extrapolation and fill in and all of that, but there was enough hidden bias in that the model learned the target leaker portion of it, which is when a home actually goes and gets sold, it has the richest data. So it caught on to the richness of the data somehow. And it is very hard for us to detect that. And in the world of predicting home sales, it's very hard to do an A/B test, right? And it's not like the consumer space where you have an enormous amount of data and you can look at that. Those types of problems, those hidden target leaker problems, et cetera, happen in so many complex ways in enterprise domain. And it really takes a very strong statistician or somebody who understands how to probe the model in very scientific ways to really test the robustness of the model. And I suspect that a lot of enterprise applications of AI, at least in the traditional structured data spaces, have been held back because somebody built models that seem to work. It actually doesn't work in practice. People lose faith and it doesn't go anywhere. So that's an example of a challenge you encounter.
So we discussed three, right? Basically, then we discussed about obviously low amounts of data being one. Second one is the inability to run A/B type like tests at scale in enterprises. And you also mentioned things like the completeness or the richness of data, not just the volume of data, but also the representativeness and the types of hidden biases that could.
Yeah, the hidden biases, especially throwing you off.
Very good. So I know we're almost at 4:30. Just a quick call out to the audience. So if you have questions for Joseph please feel free to shoot in the chat, because Joseph and I have a lot of conversations even otherwise, and it's always a great pleasure and I learn a lot talking to him. But if there are things that you would like to ask Joseph, please put them in the chat, and we'll certainly take them in the conversation. I wanted to perhaps go into this is actually an interesting question. It's more of a business question in the enterprise space. So what are your thoughts on this? Came from one of the RSVP as well. What are your thoughts on monetization, data and AI monetization in enterprise applications outside of license? So today, a lot of applications seem to be, especially in the enterprise space, seem to be sold through license. And do you have thoughts on monetization in enterprises? I'm assuming it's AI monetization.
Yeah. So let me actually go back to the data portion first. So there's often a belief that data is a highly monetizable asset. In my history of 20 to 30 years, what I found is data is actually very hard to monetize, which is why there are very few really big data companies. In Fair Isaac, we used to have a saying that predictions are worth pennies, decisions are worth dollars. Data is actually useless, right? So you really need to get to actions and automation of actions. So when you go to that, then you can come up with many, many ways of monetizing. So what are high volume decisions that AI can deliver? So credit card fraud detection was an example where we had a volume of decisions rendered based monetization model, or you took a certain cut of the savings, right? So when you can provide really high value decisions, you can potentially take a portion of the savings you deliver. So this would be applicable in payments world, for example, in the fintech world. If fraud is a great example, for every dollar of fraud you save, can you get a small cut of it? Or you'll have to structure it in terms of volume of transactions, etc. But you still have a way of monetizing that. So one way to think about productizing it is what high volume decisions can you actually deliver? And then those high volume decisions, how do you actually charge for it? I think that is the most attractive one when you can do it. Then, of course, there is models where you are now delivering SaaS services that are pay as you go, but they are really subscriptions, fixed subscriptions for specific volumes of usage. And then finally, there is licensing of models and so on. The ones that I am most attracted to in general are ARR models, annual recurring revenue models, where there is a subscription involved and at a certain volume, and you are constantly improving that service with AI. It's not a static AI system, and the AI system is constantly improving, and it is delivering value to the customer on an ongoing basis, and people are paying for that.
Great. Thank you, Joseph. So I see a number of questions on chat now. Let me just take a few seconds to grok them. Maybe let's move on to perhaps companies and entrepreneurs. So there's one question. Sorry, this is the latest question, but more relevant to the topic of enterprises that we're talking right now. So the question from Amar is, most enterprises, especially non-tech ones like manufacturing, energy, health, government, etc., are still way behind when it comes to AI ML. Do you agree with that? If yes, why do you think that is the case?
So it is an easy one to agree with. But I think why is that the case is because it has got typically physical constraints. So it is not digitized. So first of all, digital transformation itself has been delayed. So where you can apply AI first is where everything is digital. And this is what, again, my attraction in going to the world of real estate, which is there is an industry that is 100 years old operating. In fact, in many parts of the world, Maybe Amar, if you go to, any of the developing world, India, Egypt, anywhere, you will find you don't even touch a computer when you actually buy or sell a home. You actually just don't touch a computer, period. And so the world of certain industries like these are so far away from digitization that AI is really an afterthought. It has to come after digitization. But that's an opportunity for entrepreneurs. I actually really believe there's a huge opportunity. That's why I went in the space I went, which is when you have very large industries, very large things. Now you can go not just apply AI, but you can actually build a platform for that industry. So today's platforms, I believe, the modern opportunity is you build it cloud first, you build it data first, you build it AI first, you build it mobile first. So when I was in Microsoft, one realization I had was AI without a platform is like a brain without a body. The platform is the body, the data schema, the actions you take, the feedback loops, everything is engineered by the platform. The data doesn't exist in vacuum. It's all engineered in the process of digitization of industry. So go ahead, enter an industry, digitize a core portion of that industry. You don't have to swallow the whole thing. You take a core portion of that industry with a platform, and when you build that platform, build it AI first, build it data first, build it cloud first, build it cloud native as SaaS services. That's an exciting journey to do, and there's still so much opportunity for that.
Yeah. Thanks, Joseph. Let me actually just double down on this, because I think in the next 20 minutes, especially for this audience, it might be worth, they might be interested in talking about ideas for companies, entrepreneurships, and so on. So you mentioned one of this, which is, hey, go into one of these traditional industries and build a platform, a cloud platform, a modern platform, with AI, with data, with mobile, on the cloud, delivered as SaaS services, etc. What are other types of areas where you feel these types of there are either platform opportunities or even big markets where that could be disrupted using AI?
Yeah, so excellent question, right? I think you have three models of monetization. One is the industry vertical. So it can be real estate, retail, you take vertical and try to build a platform in that. Another one is horizontal. So marketing as a function. You could take even narrow slices like digital advertising as a function, and then just, hey, create a platform for digital advertising. Or financial services, or fintech, or or invoice processing in finance. So that's the specific horizontal functions, because horizontal meaning it applies to pretty much every company. So everybody will have that need. And then the third vector is true platforms, technical platforms like a Databricks. And some people here have already done those things, but it has to be meaty enough. It's actually really worth asking, and maybe Vijay, you may have thoughts on this as well. Why hasn't a platform emerged for AI like it has in the data warehousing world or data analytics space? Like Databricks has emerged, we have Snowflake, and those all tend to have become meaty companies, but we don't see a similar one for AI. What do you think?
So perhaps this might be a controversial statement for this audience, but I fundamentally believe that AI is a derivative technology, right? It has to sit on top of, as you said earlier, a platform, and also having to be able to sit on data, because at the end of the day, AI is going to become like maybe just another type of technology, right? It doesn't matter. It can do a lot of things, but if you don't really have a sense of what problem you're solving, and you are in the loop of adding value to any of the processes in that domain, then there's no value in AI. So now, with that said, I do want to be a little bit careful. There are things that have happened in the last 8 to 10 years around where the companies building platforms and frameworks for building tools, right? There are these tooling frameworks. I believe there was this big big growth in them in the last about 6-7 years. I personally believe that that's probably coming to the tail end, where there are a few large AI tooling companies that have emerged out there. Suddenly, all the hyperscale clouds have now their own platforms that are reasonably good to begin with. So I wouldn't really start building something like another MLOps platform or another AI tooling platform at this stage. And there are also a couple of good on-prem versions that extend those.
Yeah, I would
now
say though that I think for those kind of tooling companies, there are niche opportunities. I think they all grow to a certain small size and then
Right.
typically get bought. Right? One company recently in the Seattle area that I was familiar with was a company called Xnor that developed very highly compressed deep learning networks that could be run on very small devices, even like Raspberry Pi and so on. And surprisingly, they got bought by Apple, and the technologies actually made it into the Apple iPhones, right? And so that it was that expertise. So I think there is still opportunities for quick hit, small scale, find a really good technology, make a product out of it, show demonstrations that then leads to an exit where one of the larger companies find it attractive and buy it because it adds value to them. And I've seen a few examples like that.
Yeah, but also just going back to the analogy, right? If you look at what Snowflake or, for instance, Databricks has become, it's taken them about 6 to 10 years to come to this scale. I think it almost feels like in the AI space, there are, as you said, there are a lot of these companies in the niche, solving some niche problem, and they do that well. And at some point in time, they hit a barrier to scale, and they have to get bought out by larger companies in order to make it, right? So it's probably not at that point of a few companies becoming big enough, owning large sizes of these platforms. I think we have still not come to that. Of course, the cloud providers, the big hyperscalers, have certainly done that because they have invested in this for the last 6 to 8 years, including you yourself did it earlier on. But perhaps that could be one of the reasons, right? I mean, maybe these big companies are the hyperscalers today.
Although the AI as a service functions from AWS or Azure or cloud, they haven't really taken off. That's not those services are not the ones that anyone thinks about typically when you actually go and build an AI model the first time, right? So it's interesting. I'm in general, I'm much more of a fan of prefabricated components in the AI space at this point in time, and I might have a different view on the point. And we have distinguished people like XD who have built great speech APIs. Some of those types of approaches still have lots of value. I mean, I think about the cloud being like a grocery store, right? You can give the raw food with which you can cook. You can have the partially cooked food you can put in an oven. And now most grocery stores like Whole Foods have full kitchens that you have ready to eat stuff. And so I think in many ways, technology have all of those pieces.
Yeah, this is an interesting question. Can you give examples of AI companies serving enterprises, reduce time to value for AI implementations, and scale up their business fast? What is their SOP of selling AI and implementation?
Yeah, good question. Well, let me take 2 or 3 examples. These days, UiPath has got lots of attention, right? Because of robotic process automation. I mean, they're not truly an AI company, but they use AI in certain places to make the automation of workflows a lot better. Now, I was really surprised when I encountered them how much traction they had actually got all across the world. Many of these business process outsourcing companies in India, etc., large ones, were all using UiPath to help automate mortgage application processing or invoice processing in finance. And lots of those kinds of applications seem to have had traction with the UiPath type of automation approach. That's robotic process automation. Then recently, I encountered a company called Indico in document automation, and they had actually built a whole sort of nice interface for document understanding. You upload PDFs, you mark areas that you want to recognize, you have actually performance metric that they display, you can give it coaching input. It uses pre-trained models. I think it uses transformers and so on behind the scenes. So processing of lease applications or real estate documents, a lot of those things become easier. I do think there is in Seattle area, there's a company called Dokugami, which is founded by the former founder of XML, who started XML at Microsoft, who's now got a document automation company, and he's bringing in concepts of XML together with the things that you would think about on document AI to take documents to a new level. So I think there are a few of these examples that are novel now that I find interesting. Then, of course, there is the traditional type of things in the finance world. People have applied lots of quantitative techniques. In fact, Charles Elkin, who's on the board of this fund, has been applying to assets like bonds, which are relatively liquid bonds, and pricing them and so on. AI has been applied there. In banking world, it's applied in credit in a big way, mortgage credit, pricing of products and so on.
Yeah. It's an interesting question here now. How to come up with ideas that can't be built by large cloud AI services companies? In other words, what are these places where entrepreneurs can work on without being that large cloud AI companies would be.
But if you mean by large cloud AI companies, AWS, Azure, and Google Cloud, I actually really think they're not making all that much progress. I don't think they're making the right platforms. I actually think the right platforms are getting built much more in the open source. The tooling is, at least. I think companies that are much more focused on specific applications in the enterprise are far more likely to succeed, because in any enterprise world, the workflow is domain specific, and automation of that workflow or transforming that workflow in some unique, creative way that so that the industry operates in a different way is the really interesting transformation. Very unlikely that any cloud provider whose DNA is just really building better platforms and tooling is going to be able to solve workflow problems in industries or aggregate industry-specific data in a way that will change things fundamentally. And in many ways, at Microsoft, I have lots of history from there where Microsoft tried to go into vertical after vertical over time. There are very few verticals where Microsoft was able to make progress by attacking it as a vertical, right? And get really sort of industry dominance. And so I have lots of hope for entrepreneurs who go into specific domains and tackle them.
Yeah. So I think the verticals are still a very rich and ripe areas. Vertical specific platforms that go deep in specific verticals still have a lot of potential.
Yeah. For example, by the way, just one thing in the real estate world, right? One of the things that we are doing is marketing automation, meaning marketing content generation. So we have an AI-driven tool for creating videos to advertise properties. So what that does is, imagine a real estate agent trying to create a video to send to someone and advertise a property. It's quite hard for an agent, right? A real estate agent or somebody to create these things. So what we did was we took pictures associated with the house. We applied AI to caption the pictures appropriately, also connected with the real estate listing. Then we put those together in a nice video. You add music. Then you can add narration if you want, synthesized narration. You can add other content into it and create a clip that actually is nice. And you can choose the music that you want to put into that clip, and you can tailor it in so many ways. And so now with one click, you can generate a video. A real estate agent can, with one click, generate a video that she can email or she can put on TikTok or Instagram or Facebook or YouTube, connected to their lead generation mechanism and CRM, and drive that. And so now we have created a system of marketing that incorporates AI as a function. And the reason it actually works is because it's not a generic piece. It actually integrates the real estate data into it and creates real estate videos that are really great. And so I think it's super important to be able to deliver an outcome that is extremely bar raising and high quality at the end. And you can deliver those bar raising, high quality outcomes only if you integrate things sufficiently that you produce something that is just very compelling. And I think that's why verticalization sometimes is important, because if you stay at the platform and tool level, you're not going to achieve that bar raising outcome. And lots of human variability come into creating the outcome. And here, if you can stitch it all the way together without that human variable to create amazing outcomes, well, then it becomes differentiating enough to create a company.
Thanks, Joseph. So I think you've just answered the question very powerfully. How to come up with ideas that can't easily be built by large cloud AI service companies, take a vertical and build experiences that are optimizing for outcomes, use AI as part of it, but be very deep in the domain and aim to generate value. I think those are areas where the large players typically struggle to get that level of penetration or deep domain expertise and dominance.
Right. I mean, I think you need 10x, 100x better outcomes, so to speak. I mean, I think the outcome has to be so incredibly compelling. I think that's what people should focus on, which is, are you going to be able to create a particular outcome when you start a company in a way that is like 10x better than something that exists? It's not good enough when you're starting a startup because of all the other overhead associated with the startup and everything else required to be 2x, 3x, 4x, 5x. You just have to be at least an order of magnitude better in some metric, right? In some metric, you have to be an order of magnitude better. Yeah.
So a question earlier on, this is now from chat. It's a different one. So this is more technical question. So what are the hardware related bottlenecks for AI ML applications?
I actually think the hardware bottlenecks are sort of secondary to the data bottlenecks. So usually data, accumulating enough volume of data in a sustainable way, like, and organizing it and making it even ready for machine learning tends to be the harder part of it. And today in most of the enterprise space, I really think the hardware is not really the bottleneck at this point. It really the rest of the physics associated with gathering, organizing data and building models and so on. And once you have your arms around the framing of the problem, hardware bottlenecks can be lifted relatively easily. And that's my view. I mean, Vijay, what do you think? I mean, I think there are specific areas where, you know, internet scale companies, like whether it be an Apple or a Facebook or even Pinterest, etc., they may find hardware to be a big cost item that, you know, justifies calling it a limitation, but it's really sort of how much money you want to pay for it.
Yeah, I agree. I think, as I said, it's if you are in applications like search or discovery or recommendations, or even personalization, where the last 2 to 5% translates to a large economic value, then I think hardware becomes the bottleneck and it makes sense to invest. But by and large, I would agree with you that, especially given that most enterprises at least don't have that much data to begin with, it's probably unlikely to be the main bottleneck.
And again, with the advent of the new transformer type approaches where there are pre-trained models to be tried, you know, at least to bootstrap and sort of build the entire prototype to a certain level of performance. I mean, I think you don't need a tremendous amount of hardware. You can bootstrap once you get conviction in the product and that it actually fits, there's a product market fit. Well, then you have conviction to invest in the money to actually bring in the hardware to take it to the next level of performance.
Yeah. So just along that line of going deeper into industry and building those very high performant applications that are maybe order of magnitude different in some dimension of outcome or experiences. There's a question here. Do you see automated machine learning enabling domain experts to use AI at scale? Or rather, domain experts meaning non-technical AI ML users, so-called citizen scientists, citizen data scientists?
Yeah, it reduces friction, certainly, right? I mean, but I think it's far from being a silver bullet. I think if you look at, say, let's take a radiologist analyzing X-rays, right? So you can take that question and say, will automated machine learning enable a radiologist to create a better radiologist? Well, so yes and no. And if you are a really smart radiologist who understands the the right way to organize data, have stratified sampling, have the right proportion of data, imbalanced data sets, building it the right way, doing the right testing, meaning the right statistical testing, and equivalent of randomized clinical trials if you want to have high clinical confidence in these things. But if you understand all of that, well, then that portion of just doing the learning, once you're structured experiment, could be a lot less friction. And I think where the automated machine learning kind of approaches might come in is make a recipe a little more clear to you, of the sequence of steps that you go through, or it automates for you and produce an outcome so you can refine. So in many ways, to me, automated machine learning is just like every other tooling that you are building around this whole process of problem solving into space with data. And I think it's a very good tool. It allows you to explore the space of models, and that's very good. And again, that final fine tuning, you can automate a lot of the exploration of that. You can explore different architectures. All of those are welcome, but I don't think it solves the biggest bottleneck of problem solving that anyone has to do.
Yeah. So Joseph, that's a very interesting segue, right? So does this mean that in order to gain, and I'm purposely stating this more as a leading question, that for AI to really gain adoption and drive a lot more value in like industries, we should have less AI people, but really build tools for the industry domain experts to how do they manage data, how do they figure out, how do they label what data, teach them more about all the data lifecycle for AI, treat them to basically educate them, and then abstract away the core Aiml AI pieces itself. So where it just becomes something like an Excel function where you say, hey, optimize it for this space of functions. And I think today there are various names for this, including like software 2.0 that's starting to claim that, hey, at the end of the day, you give data, you give your objectives, you tune the data. And I guess even recently, Andrew Ng has been talking about this more as data-centric AI. Yeah. Is that going to be the future to drive AI adoption at scale?
Yeah, and it's a really good hypothesis. There's one side of me, honestly, that wonders if AI isn't just like digital signal processing. So it's if you just look at signal processing, there's almost amount of complexity. There's adaptive signal processing. There's a lot of those things, and I don't remember in the world of signal processing conversations like, let us democratize signal processing. What I think it went into was it was a specialized field. Specialists applied it, and there were, whether it be chips or DSP software or routines. I mean, there's a whole collection of competence developed around it, and then digital signal processing just disappeared into the background, into devices, into every place where it was truly required. And I wonder if there are in many aspects of AI that will be very similar to that. It will just sort of disappear into the background as routines that are used in various places. And then there may be other types of AI where some of what you said might be actually, the way it percolates. Honestly, I wish there was clarity here. Vijay, if you have more clarity, you should elaborate on it.
Yeah. So certainly, I think when we try to build, I mean, even from my own experience here in ServiceNow, when we try to build vertical specific AI applications, typically, when people earlier used to claim, hey, data munging, I mean, just to build models alone, data munging is about whatever, 70, 80, 90%, and then the model is 10 to 20%. But it goes, I think, beyond just data munging. It's not just the pre-processing, which is part of the machine learning lifecycle, but just the full application development lifecycle. Should it become more automated, and should we put that in the hands of domain experts, industry domain experts, and give them the tools where they are managing the data, they are able to curate the data, they are able to look at the performances, they are able to figure out where the model is doing well, where should they trust it, where should they not trust it, and in a sense, teach the system, right? So effectively domain experts teaching the ML system as opposed to
Right.
AI engineers and AI scientists solving the problem.
Yeah. I think
I
that
do
makes sense.
believe that's probably an area. And recently, I think even some companies like Snorkel and a couple of companies have been starting to look at it. That certainly sounds like a promising hypothesis.
Yeah. And I think related to this, one question that was on the chat was, how do you really pick up on the domain specific issues in order to come up with such solutions? How did you go about it when you first started into the real estate domain? So in my own world, right, when I started in the real estate domain, I mean, I really sort of shadowed the participants in real estate, meaning like real estate agents, and I looked at how they actually work. And now knowing AI, having built platforms, when I looked at how their work actually gets done, and I can trace a particular real estate purchase from a person selling it all the way to the buying side, and I can sort of shadow it. I understand all of these areas that are ripe for automation, all of this paperwork that's unnecessary, all the lack of digitization. And that, gave a hypothesis on how to go after solving the problems and what then mattered. It's crazy, by the way, even in real estate, like many of you bought and sold real estate. But let's say a buyer actually signs a contract in DocuSign. So that part looks digital. But then guess how that contract is transmitted to the seller side? Somebody actually extracts a PDF out of the DocuSign, sends it over email. On the other end, the person actually uploads that PDF in the DocuSign again, marks all the things he had to sign, then the other person signs. And then again, the PDF download and transmission happens, right? It's just not integrated. So when you look at a lot of those things, you get a prioritization of problems to go after. And then there are certain areas where AI can make enough of a difference, and it's also marketable sufficiently that you invest in that. And then there are other things that are, you just have to do it, grunt work that you just do to make the whole thing come together.
It's awesome. I just want to be sensitive to time. I know we are about 5 minutes past the time we were supposed to end. Any last thoughts, any final questions for this? I mean, any final things you would like to share with this audience?
Yeah. Now, one thing that I really think is very important in the next 10 years is assistive AI, right? I kind of think of AI to empower AI in the sense of artificial intelligence to empower assistive intelligence. So assistive intelligence can be software also. That's why I said AI to empower AI. And I think most industries are physically constrained outside of a few areas that we all know as purely digital. In those areas, the application of AI to really increase human productivity and then really bring about the natural intelligence of the human next to the AI in a workflow, and then convert that combination into services with APIs. Like MechTurk was an example of just pure human intelligence put on an API. Now, human intelligence plus AI with an API would be very interesting because it can integrate into the rest of it, right? I think that area is actually really exciting. I think we want to think about every operation in every industry as a service, and that service has software elements, AI elements, and human elements. And we've got to use software to glue all of those things together and deliver APIs that can be then integrated into much larger applications. I think that's the way I think would go. There was a question here about neuromorphic computing. Now, technically, things like neuromorphic computing actually are very interesting, but I suspect those things will take a decade before it becomes even practical. In the short term, there is something much more rudimentary, which is put human in the loop. Okay, so the human in the loop AI is as a service. Human in the loop AI as a service is a very, very interesting area to think about and create applications around.
Yeah. Yeah. So Gang Hua, who's one of our fellows as well in the fund, had a point earlier. Had a question earlier. I agree with your comments about vertical. You must be familiar with the notion of first-party application equals third-party application. What's your opinion about big companies building AI solutions around their own business verticals and then wrap it to sell to third-party companies with similar applications?
Yeah, no, really good question. Yeah, in Microsoft, we used to say first party equal to third party, especially in the Bing world. Look, I think companies, almost every company is trying to become a platform company. Every smart company is trying to become a platform company. And so this particular question relates to that in many ways. Let me just take Amazon as an example. Amazon was an online retailer, but very quickly it platformized every component of it. It platformized its fulfillment center as FBA, fulfillment by Amazon. It platformized its payment system as Amazon Payments. It had web store by Amazon, which is very similar to Shopify. And then the platform, e-commerce platform, was the one on top of which third-party merchants sold. Now, 80 to 90% of Amazon's physical volume is actually sourced by third parties, right? It's third-party marketplace. And they are actually storing things in Amazon warehouses. Amazon's customer service is serving both third parties' needs, the third-party sellers' needs, as well as its own. And what happened in that process was Amazon essentially became Amazon Retail. Forget AWS for a second. Amazon Retail itself actually became a platform for other participants. And even Amazon's fulfillment is actually run by contract people. It's like they're like Uber, right? So they just platformized the hell out of it. Like they platformized what was a vertical. And I think companies like the banks, etc., are somewhat aware of it now. Some of the leading banks are going into it and essentially taking the core and platformizing it, so it becomes the way that particular industry operates. There's tremendous nonlinear value in doing it. It takes a very smart product developer to conceive of what that product is and actually really lay out the network effects associated with it. Now, if you all haven't read this blog, there's a great blog by James Currier of NFX Partners. NFX stands for Network Effects, saying the next 10 years will be about market networks. Now, I think everybody is familiar with social networks, right? Social networks are people coming together and exchanging social interactions, messages, photos, social interactions. A market network is a set of market participants, service providers. In the world of real estate, it would be real estate agents and mortgage providers and title and escrow and inspectors and people like that. These are all service providers who are involved in the conducting of a prolonged transaction. And market networks are about people who are service providers coming together in a network. And the market network enables the exchange of information in reliable ways, in trusted ways, and the entire workflow becomes more fluid with the application of AI and data. And so I think companies that use approaches like that with network effects and platformize their competencies for an entire industry are going to be the next generation. And why is that happening? In many ways, you should ask the question, why now versus before? And it really is, at the end of the day, the cloud and the communications capabilities that have emerged in the last decade or so, right? And that has just made the concept of a market network feasible. It was not feasible before in the same way that's feasible now.
That's awesome, Joseph. So for folks in the audience, so I've just put the link to the blog that Joseph was referring to, Jeff Currier's blog on the next 10 years of market networks in the chat window. There is one theme of question. There was one question earlier, if I remember, I missed. Let me make sure I block it. So there was something about synthetic data.
Maybe we'll take one more question, Vijay, since we are off.
Perhaps the last one. Can we do the last one?
Yes, that sounds great.
So what are your thoughts on potential breakthroughs in the synthetic data space in the future? I'm assuming the question is, okay, synthetic data space for AI future.
Yeah, no, I think that's a really great question. Look, I think within the enterprise world itself, I think you can think about setting up, the teaching mechanism for AI, which involves synthetic data, and synthetic data in areas where you can use equations and physics to generate lots of variations in a particular domain. There is like tremendous opportunity to create the learning curriculum for an AI model or a set of AI models. I think that is great. Along with that, I find concepts like Snorkel very interesting, right? I think that is synthetic data in an informed way. And if people here aren't familiar with it, just look at snorkel.ai and some of the papers published by the Stanford researchers associated with it. And I think that approach applied to a variety of domains has lots of legs. I think, but it is still industry specific because the way you have to model the data generation piece is very, very vertical specific. So yeah, it's an exciting area. Vijay, what are your thoughts there?
No, I completely agree. I think the trick here is going to be how well do these synthetic data sets reflect the physical underlying causes of any processes, right? How well are you able to model the physical processes that generate this data is going to be super important.
Yes.
And I think the models that you ultimately build on top of that data will have as much fidelity as how well is the
yeah, it's garbage in, garbage out, absolutely. And so I think that's where the interesting thing is, maybe there are portions of the problem that can be governed by good deterministic physics equations. There are portions of the problem that require statistical learning. So when you can bring both of them together to create enough data set that truly represents the richness of that system with the right causal effects, well, then you can now learn something that can interpolate and extrapolate better. Yeah.
So,
and by the way, one thing related to this, because Vijay, you have the physics background, I've heard of AI being applied in the solving of very large systems of partial differential equations.
yeah,
I thought that was really, really interesting, an example of some of physics and statistics coming together.
Yeah, so if you're familiar with especially flows, there is this very classical partial differential equation called Navier-Stokes equation, which is a very highly nonlinear equation to solve for modeling flows. And recently, Anima and Kumar and team at Caltech gotten much better solutions to Navier-Stokes, the state-of-the-art solutions to Navier-Stokes using deep learning. So it's and even in like areas like pretty much any type of nonlinear inversion problems, and there are a lot of these things in physics.
Exactly.
Seem to be DNN is just deep learning is just continuously hammering one after the other.
Yeah, it's
a
wonderful time.
I just
pause here, Andrew.
Yeah, I just wanted to say thank you so much, Vijay and Joseph, for spending the evening, afternoon with us. And I wanted to thank the audience as well. You know, as a reminder, we are growing at Fellows Fund, hiring part-time investors. So please reach out to either Alex or I if you have any questions. And looking forward to doing this again soon.
Wonderful. It's been great to have every one of you as an audience, and thank you for hosting us, Andrew and Alex. Vijay, thank you very much for hosting it as well.
Thank you, Andrew. Thanks for joining. And thank you, Andrew and Alex as well. And thanks, everyone. I think the fact that there are 70+ people hanging on 15 minutes past the end time means that it's probably enjoyable. So thank you.
Thank you.
Thank you, Joseph.
Bye-bye.
Oh, thank you.
Bye, everyone.